we use boiling point and melting point as the measure of the strength of interactions. And here's how this works. So either as a solid form or liquid form, the particles have some interaction to one another, but at its boiling point, all particles become gas. At gas phase, all these particles have no interaction to one another, right? So the energy that destroys this interaction will reflect in high or low boiling point. The strong interaction, so high boiling point, the weak interaction, so low boiling point, okay? So we also use melting point for those whose boiling point is too high to measure. So basically like gold, with how you're going to get to the boiling point of gold. We can melt it, but I don't think it's going to be very difficult to reach the boiling point of gold. Gold becomes gas. It's really difficult to see. Anyway, all right, so concept test, which compound exhibit a strongest and the weakest force of attraction? Well, so the boiling point is a measure of strength of interaction, right? So sodium chloride clearly the highest, so require over 1,000 degrees Celsius to melt sodium chloride. To boil sodium chloride, right? So the strongest interaction. And the weakest interaction, ammonia, not even a liquid at room temperature. This is the gas at room temperature. Okay. We're going to use a little bit physics here. So we have Coulombic forces, which is the interaction between positive and negative charges. All right. So if you look at this interaction right here, so there's a force, the attraction, high or low depends on, first of all, the charge. Right? If the two particles have high charge, I'm talking about like +2, +3, +4, -2, -3, -4. So the higher the charge, the stronger the interaction. Yeah? And another factor that highly affect the force, the Coulombic force here, is the distance between the two. So this is R squared, so R is radius. Right? So basically it's the distance between the positive and negative charge. All right, and so you can see that the Coulombic force is inversely proportional to the distance. So high distance, which means they are far away, and the force is low. Okay, so and you see the square. I mean the relationship between these two is exponential. All right, so my point is, strong and weak interaction depends on the charge of positive and negative particles and how tightly they're packed, how close they are, basically. Okay. All right. The first type of interaction, we're going to talk about the ionic compound, ionic bond.